This is geometry. This is Unit 5, Day 1. We're going to talk about finding the angle measures of most any polygon. We're going to start out by looking at a triangle. Draw any type of triangle you wish. You can draw any type of four-sided figure that you wish. A pentagon and a hexagon. Okay. Notice here we're going to say that n equals the number of sides. We're going to talk about how d is going to equal diagonals from one vertex. And we're going to talk about how the triangle is going to equal the number of triangles formed by the diagonals. Okay, so in this case, we know that n is going to equal 3. A diagonal is a segment from a vertex to another vertex through the inside of the shape. So a triangle doesn't have any diagonals. So how many triangles are formed? There's only one triangle that's here. In a four-sided shape, we have four sides, the diagonals from one vertex, there's only one diagonal. It wouldn't matter which vertex you came from, there would only be one diagonal. We don't want to count both of them because we don't want to watch where they intersect. So the triangles that are formed, there are two triangles that are being formed when you draw on your diagonal. Five-sided shape. Pick any diagonal, or pick any vertex that you wish. Draw on your diagonals. Those are segments to other vertices through the inside of the shape. So there's two diagonals. Remember that a side is not considered a diagonal. It's only to the other vertices. It's called the non-consecutive vertices. The numbers of triangles formed would be 3. In a six-sided shape, notice that we would have 3 diagonals, and that would give us 4 triangles. So what can we do with this? Well, what does a triangle mean? A triangle, we've known from the past, always has the sum of 180. All the angle measures, this angle, plus that angle, plus that one, plus this one, and this one, is going to account for all of the angle measures of the interior of this shape. Notice how the measurements are not overlapping and they account for the complete angle measure at any vertex. So since this triangle has 180 plus this triangle has 180, that's 360 degrees total. We can use the same type of math to figure out the sum of the interior for any number of sides. Looking at our triangle, there are 3 sides. There's only one triangle. So we're going to take that triangle and multiply it by 180 because the sum of the interior is 180. A quadrilateral had two triangles with it, so we're going to say 2 times 180, which gives us 360. Our pentagon, the 5-sided shape, we can get 3 triangles out of it when we draw in our diagonals. So that's 3 times 180, which is 540. From our hexagon, which has 6 sides, we get 4 triangles, which is 4 times 180, which is 720 degrees. So notice that every time we look here, the number of triangles is 2 less. Minus 2 gives you 1, minus 2 gives you 2, 5 minus 2 gives you 3, 6 minus 2 gives you 4. So to figure out the number of triangles, it's always 2 less than the number of sides. So let's look at a heptagon. A heptagon is going to be considered a 7gon, otherwise known as having 7 sides. Sometimes you'll have questions that talk about a 12gon or a 28gon. That's just so we don't have to give it a specific name. Some of the big names you won't be as familiar with, but a heptagon you might be. We typically wouldn't say a 6gon or a 5gon. You're pretty familiar with pentagon. But for ones that get bigger, especially bigger than 10, for the most part those will be a number followed by gon, and gon actually stands for sides. Polygons, poly is many, and then gons is sides, many sides. So we know that the number of diagonals would be 4 from any vertex, and the number of triangles would be 2 less, which is 5. So we're going to take those triangles and multiply it by 180, because every triangle has 180 degrees inside of it. And when you add them all up, it counts for all of the angles inside, in this case, our heptagon. Let's see if we can come up with a formula. What are we doing? What do we need to know to do any of these problems? What's the most important value? Where can we start with? If we knew the name or the type of polygon that we had, then we would know n equals the number of sides. If we knew what type of polygon we had, then we could figure out the number of sides. So we need to know the sides. Once we know the sides, to figure out the triangles, we're going to take 2 away from it. Once you take 2 away from the number of sides, we multiply that by 180, because every triangle has 180 degrees inside, and that's going to give you the sum of the interior angles. Even if the side lengths are large or super small, we would concur that the side lengths of the polygon has nothing to do with the sum of its interior angles. So the size of it doesn't matter. The number of sides matters, but if it's really big or if it's very small in terms of the actual shape, that won't matter. So let's try a few of these problems. Our formula we've been talking about is n minus 2 times 180. So you take all the angles inside and add them up. That's going to be the same thing as n minus 2 times 180. Just for a quick reference, what is the sum of the measures of the interior angles of any quadrilateral? That will always be 360 degrees. Now, one neat concept, this is a little bit different. We're looking at the exterior angles. The sum of the measures of an exterior angles of a convex meaning that the vertices are pointing outwards. They're not pointing inwards, making a cave. They always point out. Well, an exterior angle is made by extending the side of your polygon. Extend the side, continue it out at the same slope, and you get these angles. These angles will all add up. Take each one of those angle measures. They will always add up to be all the way around the shape. It always adds up to exactly 360. So the exterior angles always add up to the same answer, but the interior angles always have multiples of 180. So let's find the sum of the measures of a hexagon. Hexagon has 6 sides. N minus 2 times 180 equals the sum of the interior angles. Well, if we have 6 sides, then we know that we're going to say 4 times 180, which is 720 degrees. So every hexagon has 720 degrees if you were to calculate all of their angle measures inside the shape. The sum of the measures of the interior angles of a convex polygon is 1260. So this time we know the interior angles, we just don't know the number of sides. We know that the formula n minus 2 times 180 is the sum of the interior. So that is 1260. We're going to divide by 180. And that gives us 7. We're going to add 2, which is going to give us 9. So this is going to be a 9-sided shape. A 9-sided polygon is called a nonagon. Here we have 1, 2, 3, 4, 5, a pentagon. It has the angles in there. Notice that there are 2 measurements that don't have any degree values, but they do have a single curve, which is called a tick mark for an angle. And because they're both a single curve, single tick mark, that they are the same measure. So we'll call each of these x. So we get 68 plus 105 plus 109 plus x, and it has to equal a 5-sided shape. If n equals 5, then 5 minus 2 times 180, 3 times 180 equals 540. So we know that all the angles need to add up to 540. 68, 105, and 109 adds up to 282 plus the 2x still equals 540. Subtract the 280 across, and that'll actually come out to 258. Divide by the 2, and we get 129. So both our x values are 129 degrees. Notice the picture. Notice what they're giving you. They're giving you the exterior angles. the exterior angles always add up to the same amount. Doesn't matter the number of sides. So they always add up to 360. Adding our constants together, we're going to get 3x and 174. Subtract the 174 will give us 186, and dividing by our 3 will give us 62. So that means we have x that equals 62, and we have 2x, which is going to equal 124. So those are our two unknown angle measures. For the last question, the base of a lamp is in the shape of a regular nonagon, so it has 9 sides. Find the measure of each interior angle. This is a regular nonagon. A regular polygon has all the same angle measures and all the same side lengths. So to calculate out what the value of each angle is going to be, n minus 2 times 180 divided, that's the sum of the interior. Now, if they're all the same, then we can divide by the number of angles, and that's going to give us each interior angle of a regular polygon. Very similarly, if we have the exterior angles, which is always 360, and if the exterior angles are all going to be the same as it would be for a regular polygon, then we can divide that by n. And that's going to be each exterior angle of a regular polygon. So in our case, we know that n equals 9 because it's a nonagon. So we're going to say 9 minus 2 times 180 divided by 9. 7 times 180 divided by 9. That is 1260 divided by 9, which is 140 degrees. Each angle on the inside of this nonagon has to be 140 degrees for it to be a regular nonagon. For the exterior angles, we're going to take 360, divide that by the number of sides, or really the number of angles, and that would come out to be 40. Well, of course, the exterior angle and the interior angle add up to 180. So 40 and 140, of course, is 180, so that worked out great.